So it's for me, it's very exciting to see all of you here online. We are finally hosting this Space for Resources Forum, and in these 2 days, I think we will have a very wonderful discussion, particularly between Chinese expertise and international friends. I think it's very important to really proceed with more collaborations, international collaborations. So I hope to take this opportunity to briefly talk about our company, Origin Space, and very importantly, it's not only about what we have been done, but more importantly is that we hope to invite more young students, young talents to join us, to join this field. I mean, space mining is a very international, should be a very international effort. So we hope to bring in more brilliant young students to particularly in China to join this field. So our company established almost 3 years ago. Still is the very first and currently only commercial aerospace company in China dedicated to explore and utilize space resources. And the company's long-term goal is to discover, explore, develop, and utilize material resources such as metal, water from near-Earth asteroids to better serve the space industry and human activities in space in the future. So Origin Space was founded by quite an international scientific team and also aerospace technological teams. And we have already received funding to support our missions, which I will briefly talk about. And we have already established close collaboration with broad aerospace companies worldwide. And I want to explain why we name our company called Origin, because we believe that asteroids keep the most original information about our solar system. So these small bodies will not only tell the history scientifically about the history of our solar system, but also will lead the future of human beings, where we are going and why we are exploring the space, how we are going to explore space in a new fashion in the future. And certainly we're aiming for asteroids, as many of these companies worldwide. I think it's possible to mine under current legal frame. That's very importantly. And also some of the nearest asteroids needs less energy to go compared with the moon. So we can actually take something back to the nearest orbit. So our current business model is building space telescopes and serve universities and entities who is interested in space data, astronomical space data. And certainly why we're doing it, because using these multi-wavelengths, different aperture, different characteristic telescopes, we can find and characterize more nearest asteroids. We can determine our pick up our mining targets for the future benefits, and we can also sell astronomical data and the observation time of these space missions to interested bodies. So we have already designed, manufactured, tested, delivered the very first, we call it Yang-1, basically looking up in English, Yang-1 #1 satellite in orbit, and we're taking data, doing data calibration analysis by ourselves. And on the other hand, relevant mining technologies can be applied, as you know, to space debris removal, and necessary technology can be applied to anchor asteroids and capture asteroids, things like that. So these technology can be developed and should be applied to future space industry market. As we have seen in the last 10 years-ish time frame, many of these commercial space mining companies has been established worldwide, and we are the only one in China for the moment. Actually, commercial aerospace has just been opened up in China 6 years ago. In the last 6 or 7 years-ish, more than 300 commercial aerospace companies has been established in China. So you can see many of them, but most of them is doing rocket business like SpaceX, satellite manufacturing, data services, a little bit. So none of them is actually doing space mining related business. So here is a small video we put together to actually the video really show to people who is not familiar with the field. So basically, we have seen almost 30,000 near-Earth asteroids waiting to be mined, and potentially there are millions, even more. And we are promoting this field by launching small missions for the first steps, so people can see real data we are taking with a commercial space telescope, so people can see we are doing real missions, and we are trying to demonstrate the our vision through small missions, not deep space missions yet. So let me talk about these missions one by one. So we hope to build up a satellite network with multi-wavelength capabilities to observe the universe. So last year, actually 2 years ago almost, we launched a so-called Lobster Eye X-ray telescope, which is a service for universities in China, which has large field of view X-ray detector, which can monitor galaxy clusters, and the related technology can be used to for future deep space missions, which can use X-ray to determine elements on either lunar surface or asteroids. And we also helped to launch the fourth CubeSat. It's a 6U CubeSat aborted with a UV camera observing the universe. It's a dedicated CubeSat for middle school education purpose. So you can see hundreds of these middle school, high school students participate in this mission with different parts. Could be engineering part, could be data analysis, could be mission design. So it took them 3 years actually to, from high school year 1 to year 3. So they participate in the mission since the very beginning. I think it's very useful method or methodology to attract young students from high school and let them have a better idea what aerospace is doing and what space mining or space telescope, how to operate one, how to build one, how to think about the future missions. So I think it's very interesting that a commercial company have, with our far future vision, we can help more students to have an interest in this field. And last April, we launched the so-called Near Earth Object number 1, or you can call NEO for short. This satellite was dedicated to demonstrate a net, how to use a net to capture a mock asteroid attached to a satellite. So this is very, very early stage technology, but we hope to have more, along this pathway, we use more future missions to develop this technology. And with the onboard propulsion system, we can, after capturing the mock asteroids, we can change the orbit. So the satellite has been in operation for more than half a year. We actually use onboard camera to take a lot of beautiful pictures. So this is also kind of advertisement video. We can show people that it's so beautiful to take all these videos from space using our own, very kind of very cheap commercial satellites. We practice how to operate, how to smoothly have interaction with the satellite, and we have taken all these kind of beautiful videos with different parts. Test. We have 4 onboard cameras, so we can use these cameras to take different kind of pictures. So the satellite was launched with Changzhou 6 commercial rocket. So I think it's very important that we, as a commercial company, we finish this mission as a first completed mission. And then we move on to Yangwang #1 satellite. It's a very first Chinese space telescope with optical UV capabilities. China has launched many satellites, but very few has been dedicated to space science and space science research. So this is the very first one for optical and UV telescope. It was launched about half a year ago. As I mentioned, it has both UV and visible light capability. It has 2 cameras, both large field of view. So these are related parameters if you're interested. The orbit is 500 kilometers LEO orbit, solar synchronous orbit. So this photo shows before launch. We're doing the final test. So this is the first light, just 3 days after the launch. We targeted the Large Magellanic Cloud because this target cannot be seen from China. It's in the very south, cannot be visible from China. So that's why we took this photo. So as you can see, it's a very large field of view. One shot can cover the full object. It's about 9 cross 9 degrees. So we have 2 cameras. So on the right hand side, you can see optical camera photo of the Carina Nebula. But on the left hand side, you can see only the very massive stars is emitting near UV light. That's how we can distinguish the very massive stars from the messy cluster, just for example. And we are also doing the full sky surveys. This is just for demonstration. We actually completed the whole galactic plane survey and almost finishing the full sky survey. So you can see each square here is basically one shot, and we're taking the data analysis and put all of them together with people in our company. So we are designing the payload, designing the platform, and this year we are having the capability for AIT, assembling integration and the test with our new center in Nanjing. So and with we're also developing the data analysis software, so we can provide data service from this year. And let me show this first. So this is Leonard Comet, the recent comet visiting coming to near Earth. So as you can see that from space, there are many interesting things to talk about, but this is just a video. I just briefly show it here. And this is many meteoroids what we have seen with our telescope. And this is a particular mode you can see many meteoroids. We have seen hundreds of them. We spent, I think, 10%-ish time taking interesting photos. We also hope to explore the potential scientific potential science could be done with this kind of meteoroids observations. There has been some experts approaches us, so we can talk about how to, take the right photo to help people to do the analysis. So this is a Milky Way that we are taking together. So sometimes we also turn around the camera back to look at the Earth, so we can see big cities in worldwide, and sometimes these kind of night light data can also be useful for economics. I will talk about it later on. And our photo about this lunar comet also was selected and appeared on this astronomy picture of the day last month. So you can see aurora, satellites, meteoroids, air glow, and also the comet. So as you can see, Yangwang #1 telescope has been officially awarded a permanent observation observatory number by AAS by American Astronomical Society. So we can see many satellites here with the capability to see asteroids and comets. We have seen many asteroids and comets already, and compare with data from ground-based telescopes. So we 2 days ago we have a paper accepted by a remote sensing journal. I hope to share quickly with you. So as you can see, this is a so-called Great Bay Area in China. You can see Hong Kong here, Macau, Shenzhen, Guangzhou. So it's a Great Bay Area, and if you use the VIAS satellite to take a picture of it, it's not very high resolution. And there is a so-called Luojia #1 satellite launched 3 years ago, and you can see it much better. But actually, Yangwang #1, although designed for astronomical observation, but actually when you take a photo of the night light environment of the Great Bay Area, it provides you a very good high-resolution large field view data set. So as you can see, so if you zoom into some details, so this VS cannot see very much details. This is Luojia #1. This is our Yangwang #1. So it provides a very good resolution. So if you zoom in, you can see the difference. Okay, you can see the difference from VS to Luojia to Yangwang #1. So we actually taking some interesting analysis these days. If you compare Luojia and Yangwang data, as you can see here in red, shows lights was not appeared 3 years ago with Luojia's data, but appears on Yangwang 3 years later. So you can see only 3 years. There is a lot of difference in the Great Bay Area. That means the economics has been developing so fast. We have 3 offices today, and our headquarters is in Nanjing, next to Nanjing University and Purple Mountain Observatory, and our Beijing office is right next to Peking University and Tsinghua University, which are 2 top universities in China. So we hope to get more young students to join us to actually have an idea, have a confidence that space mining industry could be growing into a bigger opportunity for them as a career path for them to consider about. So this is our Beijing center and the headquarters of our company in Nanjing. So not only about what we have established and completed, but we hope to this year we hope to launch more missions. So this is the next one to be launched in April or May, depends on when the rocket is going to launch. So it's a small CubeSat. So basically what we're hoping to do is to uh, okay, group plants to in a CubeSat. So you can see we can take data from the environmental with our sensors with environmental detection. So with cameras, you can see the Earth first of all, and also it's basically is a ecosystem, very small ecosystem within the small CubeSat, with all the five windows transparent, open to the space. We hope to maintain a suitable ecosystem in the environment within this CubeSat. We can control the temperature, control the related parameters so that it can at least grow the plants for half a year. That's our goal. It's a collaboration with universities in China. And our effort has been spread out on the news. There are many reports about our effort for space mining spacecraft and space telescopes. So also for more future missions. So first of all, we are talking about Yangwang #2 telescope with better UV capability, with a larger field of view, and the Yangwang 3 with although narrow field of view but deeper. We can go deeper with a larger aperture, things like that. But we also think about the deep space missions. That's our goal. We are targeting for deep space missions to prepare our future mining exercise. So this is a phase CubeSat, potentially hazardous asteroid CubeSat exploration mission. So we hope to characterize the PHA apophis with an imager and a spectrometer to address key constraints to planetary defense and asteroid mining. We hope to demonstrate a relatively low cost, short duration, but high feasibility investigation capability for a 6U CubeSat. And also with the Chinese lunar mission is developing so fast, we hope to take this opportunity to develop some commercial lunar observation missions. At least we can use the moon as a target to study the Earth-Moon system in terms of the small bodies. So we can observe the meteoroids' impact on the moon at the night side by remotely detecting their impact flashes, so-called lunar flash, with multi-wavelength, multi-band observations to complement Earth-based observations to provide global information on the lunar meteoroids environment. So we can study the lunar impacts because we can use them to understand the evolution of the top layer, characterize meteoroids population, quantify hazards in the view of human exploration. So we have a great idea about near Earth asteroids, asteroid bands, and we have studied many hundreds of KPOs. But I think it's very important to study the further distance objects in our solar system. So as you can see, all cloud objects has been proposed, but none have been detected. This approach to use the occultation light of OCOs, the occultation events of OCOs to help us to detect them. So light from distant stars is protected by different objects potentially. So we can use the potentially small bodies like OCOs or KPOs can shield the light from the distant stars. So that's kind of the approach people can use to find them. Although you cannot see the occultation directly, but we can infer the existence of the OCOs by using this approach. So that's why we can have several hundred millimeter aperture UV and optical light telescope. Potentially, you can see some of the events. So scientifically, it's very important. Okay, that's all I want to share with you. I think space mining is a long way to go, but we are very confident that we are developing real missions, and we are think hard about the near-term business model to help us to grow solid in a solid and consistent way, so that we can join the international wave of space mining industry. So I really hope to collaborate more experts, and really hope to welcome more young talents to join us. That's all. Thank you very much.